Hello everybody. In fact, today is the last lecture for polymers, and we are dealing with Unit 2A of the engineering chemistry. So today's lecture is on biodegradable polymers. Now, the problem with traditional non-biodegradable polymers are that solid waste, such non-biodegradable polymers, that means the polymers which are we are encountering in our day-to-day lives, they are non-biodegradable. What do you mean by biodegradable? That means they cannot be decomposed, and hence this problem of non-biodegradable polymers is that it causes solid waste problems, particularly with regard to decreasing the availability of land fills, and also the entrapment or ingenious hazards to marine life. So that means such polymers, that means which are not getting degraded, so that means they are getting accumulated in the environment, and in fact if it is disposed of, if such polymers are disposed of in the land, then it causes land pollution. And if it is disposed of in water bodies like oceans, rivers, ponds, now it is a hazard to the marine life. So that means the polymers that are getting littered or that are getting accumulated on the land, that is being ingested by the animals, which is again a danger for the animal kingdom. So that means in short, let me say that biodegradable polymers, it is an attractive option for addressing the solid waste and marine pollution problems. Now, biodegradable polymers, they do not need to be landfilled because they are normally degraded by the natural microorganisms that are present in the environment. So let me come to the definition. What are biodegradable polymers? The polymers which get degraded by the process of biodegradation. So what do you mean by biodegradation? That means the degradation or the destruction of the polymers by the involvement of the biological organisms like the fungi or the bacteria. So what are the requirements for the biodegradation of a polymer? Now, for the biological process to start, for the degradation of the polymer, the requirements are first of all the biological organisms. Now these biological organisms are present in abundance in the environment. Now second important factor is the appropriate environmental conditions. Now what do you mean by appropriate environmental conditions? It's because these organisms being biological in origin, now they need some environmental conditions for their existence and their growth, and such environmental conditions are temperature, pH, moisture, oxygen, light, pressure, etc. Now, the third most important requirement for the biodegradation of the polymer is the substrate itself. That means on which the biodegradation process will get involved. That is the polymer in question. So, this is all about your biodegradable polymers. Now, let us come to the examples of biodegradable polymers. Now, first biodegradable polymer example is poly-beta hydroxybutyrate co-beta hydroxyvalerate. Now it is initiated as PHBV. Now it is derived by combining 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. So that means 3-hydroxybutanoic acid. This is 3-hydroxybutanoic acid. This is a polymer. This is a monomer having two functional groups. Similarly, the valeric acid or the 3-hydroxypentanoic acid, this is also a monomer. Now these will combine via a ester linkage. So that means this is a condensation type of polymerization, and this will condense to form a ester linkage to give rise to PHBV. Now this is a condensation type of polymerization, and this polymer is biodegradable. Now it decomposes, this will decompose to form carbon dioxide and water. So that means the microorganisms, they will degrade this polymer to carbon dioxide and water. So carbon dioxide, water, they are natural substances and natural species, and they will not pollute our environment. So this PHBV, it is brittle in nature and it can be used in the production of drugs and the manufacturing of bottles. Now the second biodegradable polymer is nylon 2 nylon 6. Now, as I have told in the previous lectures, the nylon is a fiber, or it can also be a thermoplastic. So it is a polyamide copolymerization of glycine and aminocaproic acid. So this is the molecular formula of glycine. You can see that it has got two functional groups, that is NH2 and COH attached to CH2. So that means this is a monomer, and aminocaproic acid, that means CH2 whole 5 NH2COH. So that means this NH2CH2COH will polymerize to give nylon 2, and this will polymerize, that means the aminocaproic acid will polymerize to give nylon 6. Now the polyhydroxybutyrate, PHB. So this is the third example of a biodegradable polymer. It is formed by the condensation of hydroxybutyric acid, that means 3-hydroxybutanoic acid molecules. So these are the three important examples of biodegradable polymers. Now, how many types of biodegradable polymers are there? It can be classified as natural biodegradable polymers. So what are the biodegradable polymers that are existing in nature? So that is rubber, that is natural rubber, collagen, lignin. Now the second type is the synthetic biodegradable polymer. That means these biodegradable polymers are synthesized in the laboratory. They are man-made. So first example is polyvinyl alcohol, the polyanhydrides, poly-3-hydroxybutyrate, that is PHB, then polylactic acid, that is PLA, then beta-hydroxybutyrate, beta-hydroxyvalerate. So this was the first example that I told in the previous slides. So this is the classification of biodegradable polymers. Now let us see what is the application of biodegradable polymers. Now poly-beta-hydroxybutyrate, or PHB, is used in the manufacture of shampoo bottles. Now beta-hydroxybutyrate or beta-hydroxyvalerate, that is the first example. This is suitable as matrices for controlled release of drugs due to their favorable biocompatibility and biodegradation properties. So that means they are useful in the medical field. It is also used as a packaging material in orthopedic devices, etc. Now let us come to the third example, that is polylactic acid. The polylactic acid is widely used in medical applications like sutures, drug delivery systems, and wound clips. It is also used in some agricultural applications like timed release coatings for fertilizers and pesticides. Now the dextron, that is the first bioabsorbable suture made from biodegradable polyester for post-operative stitches. So these are some of the typical examples of biodegradable polymers along with their corresponding applications. So this is all about your polymer chapter, and the biodegradable polymers, this is a very short unit, and it is usually asked in short answer type questions. So whatever it is, the overall polymer chapter is now over. Now it is open for any doubts, whatever you have doubts regarding this polymer chapter, you are free to project your doubts in the interactive sessions that are held every week. Now besides this, you are also given notes, the PDF notes that are uploaded in the LMS, and the books are also there, the reference books are also there in the digital library, that the link of which has been given to you already. And regarding any type of doubts, this is the first unit that is completed now. So we will be shortly holding a assignment on this topic. So you should be prepared for this and submit your assignments on time. Thank you.